Hello, everybody. I'm Albert the Dinosaur, and today I'm going to tell you all about my favorite shape, my teeth, which are triangles. Let's learn all about triangles today. All right, so welcome back. And just a refresher, hopefully yesterday went okay. Sometimes we're asked to draw the lines of symmetry. Remember, line of symmetry. So just a quick review. That's basically the fold line. Like, see something like this hexagon, I could see, well, I could fold it there, or I could fold it here, or I could fold it here. Is that it? Actually, I think I see a few more. I could fold it right there. Sometimes if you turn it, you can see it better. Oh yeah, left and right are the same. I could fold it straight down there. Or I could fold it here. I see 6 lines of symmetry. Other shapes like this, no matter how I try to do it, I can't seem to fold it. And if I wanted to make it 3-dimensional, turn into a 3D shape, or as we call it, a prism, to get that 3D shape, we just take any corner, go any length you want, but then make them all exactly the same, same length, and then go make sure parallel, parallel, parallel. Notice they're all the same direction. That direction is the same as that direction, is the same as that direction. And the lengths are the same. I could say that length, and that length, and that length are the same. That's how you mark them. So then just draw this in. So this is parallel to this. It's also the same length. How about I use 3 marks? And then make this. Oops, I'm kind of slipping there on the edge of the table. Parallel to that. Maybe I'll use 3 arrows. Say that goes with that. Maybe I'll use 1, 2, 3, 4 lines. Say those go together. And you got your 3D shape. I could even do it with this little guy up here. I could do anything I want. I could go like this. Just make sure all these are the same. And then just fill it in. This one went a little too far. And I just get rid of that. Let's kind of erase it with that. Look at that. Cool. 3D prism means it's a block. But today, let's learn about triangles. But before we learn about triangles, look at the word triangle. Triangle means 3-angle shape. Oh yeah. So what is an angle? Okay, an angle is when you got a couple lines. Imagine these are lines, and how far apart they open up. So if you trace these, that's an angle. And we can measure an angle with something called protractor. So there's a little bubble. That's where you're supposed to center it. And it's kind of like, how big is the mouth? Like, open your mouth. And so as the mouth goes, we use these numbers. Now, you notice there's 2 sets of numbers. If you're starting small, look for the number 0. So start with 0. We'll start with the inside. 0, 10, 20, 30. How wide is this? How steep is it? How wide open is the mouth? How far apart are the chopsticks? 70, 80, and 90 straight up. We call that perfect, a right angle. Of course, you could keep going, but look, make sure you don't look at the inside. You want to go past 90, 100, 110, 120. Keep going, keep going, keep going, keep going until you get straight. You're at a 180. That's why if somebody like spins around backwards, they say they did a 180. They went all the way the other way. So if I draw some lines here, I'll start with a triangle, and I'll put a line. Actually, it's going to be a ray because it starts here. It goes this way. It doesn't matter how far it goes. And I'll put some other one. There we go. There's another ray. And I've created an angle. And if I want to know how big is it, I just put this right on here and make sure this line goes to 0. Unfortunately, if we had in class, we'd all be using these at your desk. And then you could look, now wait, which number do I use? Start on the one that says 0. Don't start counting backwards. Go 0, 10, 20, 30, 40, 45 degrees. We made a 45-degree angle. Some people go like that. That's how wide open that is. That's one angle. And if you want to let's just go on to there. Skip that. So now I'm going to put down a triangle. Okay, so some cool things about a triangle. I drew a triangle is that, first of all, we like to name this triangle. So when we name the corners, we use capital letters. Any letter you want. How about A, B, C? Pretty easy. There's A, B, and C. We got 3 angles. So use capital letters. And then if I measured this angle, put the bubble right on there, put this right on 0, this angle looks like goes up, 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 up to 90. Doesn't matter how long the line is. You know, the line could go further, but it's 90 degrees. So I can call that 90. In fact, since it's perfect, some people put a little box there. I can measure angle B, put this right there, and it looks like, don't say 150. This looks small. If I were to look at this angle, see, it's getting bigger, 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 but look where I'm counting. Start with the 0. 0 was, so that's why there's other numbers in case you're going the other direction. You know, if you want to go backwards. 0, 10, 20, 30. Okay, so this is a smaller angle. This mouth is smaller than this mouth. Whoa. And this one up here, now some people don't like to hold their protractor on, so they spin their paper around. We can measure this angle. And I get that right on 0. Since I'm going this way, don't count backwards. Look for the 0. 0, 10, 20, 30, 40, 50, 60. Okay, whoop, I bumped it there. Let's see, is it fit? No, it's 60. Okay, so that's 60. 60 degrees. We put little circles for degrees. There's other measurement systems where you can use degrees. And what's cool about a triangle, if you add up angle A, that's a short way, draw a baby angle. That's angle A if you don't want to write the word angle. Angle A plus angle B plus angle C is 180 degrees. Always, every triangle always adds up to 180 degrees, no matter how you make it, no matter how funny you make it. If you look at this little angle, and this angle, they will always total to 180 degrees. That's very important to know. In fact, I'm going to prove you that it's 180 degrees. And normally we do this in class. I'm going to do it to you by tearing up my triangle. I'm going to do a little magic act. Okay, I'm going to prove to you that any triangle is 180 degrees. And you can do this yourself. Just cut out a triangle, make sure your sides are straight, and then tear it up. What do you mean tear it up? I'm going to got my angles marked. Here's what I'm going to do. Watch this, little magic act. Okay? Oh no, I've torn it. I've torn it. Now I've torn my triangle into 3 parts. But now what I'm going to do is I'm going to rearrange these. I'm going to put the 3 angles together. Here they come. As I put these together, look what happens. You get a straight line. Perfectly straight line. And remember, I'll just turn this around like this. Here we go. Slipping around on me. Any line is 180 degrees. Let's go like that. So now if you want to switch them around, you can. Or how you do it, the 3 angles will always make a straight line. And what's a straight line? Well, remember, all the way across is 180 degrees, a straight line. So remember, the sum of the angles, we say the sum of the angles in any triangle always adds to 180. Here's a protractor. So if I drew a triangle with 2 50-degree angles, like if I did this here, and I kind of drew a line into 50, 0, 10, 20, 30, 40, 50. Whoops, I'm trying to draw on that. There's 50, and then maybe I'll make another 50-degree angle. Try this again. I'll move this over here. I'll get to the end. Of course, I would use a ruler and make this nicer. And then, oh, I'm over on this side now. So let's see, I'll go 0, 10, 20, 30, 40, 50. I'm trying to do this here. This is not easy. 50. Right there. So that's 50 degrees. And we'll move this out of the way. And so this angle here was 50 degrees. And this angle over here is 50 degrees. What must this angle be? This one right up here. Well, if everything's 180, I could go 50 plus 50 is 100. So I need 80 degrees more. And it's true. I could put this on here and try to spin it around, get one side lined up. And of course, it's a terrible drawing. And you see that number right there. It won't let me draw, but that number right there is 80. It doesn't matter how big or small, but that's 80. Okay, so Every triangle is 180 degrees. 50, 50, and 80 makes 180. Okay, so sometimes we like to classify the triangles. Okay, so when we draw triangles, sometimes we like to break it into 3 groups. If you draw a triangle that has a corner in it, we call it a right triangle or a right angle. So if there's could be like a little box right there. If you made a corner, kind of like I did, and you have a 90-degree angle, you call this a right triangle. If you happen to have a gigantic angle like this one, look at the size of this angle. That's really big. Imagine that was a gigantic Pac-Man. There he is, right? There's an evil Pac-Man, right? With big teeth. Okay, see how big open his mouth is? That would be an obtuse angle. So you would call this an obtuse triangle. So here's another one. This angle here is so big. Obtuse means big. I think of the word obnoxious. It's like a person with a big mouth. If there's an angle bigger than 90. And lastly over here, if all the angles are small, we call it acute. They're all less than 90. Each one of these angles is small. We just say, oh, it's small and cute. It's an acute triangle. Sometimes we like to describe the triangle based on the sides. If you made all the sides perfectly the same, where they're all the same length, we would call this one equilateral. Sometimes we like to describe the triangle based on the sides. If you make all the sides equal, and we marked them, see the 3 lines? We call them an equilateral triangle. It's perfect. All 3 sides are the same length. Maybe this is 10 inches, and this is 10 inches, and this is 10 inches. We call it equilateral. And speaking of equilateral, what do you think the angles would measure? If the sides are all the same, the angles would be the same. What you think about that? What's 180 degrees divided by 3? If you make 2 of the sides the same, just 2, we call it isosceles. Okay, it's kind of a funny word. I think it sounds kind of like ice cream. And why do I think of ice cream? Well, if I look at this one here and spun it over, I'll just put a scoop of ice cream right in there. See, it's the ice cream cone, but we'll put him back. Okay, so this is called isosceles when 2 of the sides are the same. And what's interesting, if 2 of the sides are the same, then these 2 angles are the same, or these 2 angles are the same. And lastly, we've got the scalene triangle, where it's all different. Okay, nothing's the same, nothing matches up. So you'll hear me say these words. Okay, can you name these triangles 2 different ways? Give them a double name. Okay, pause the video, think of what they're named, and then I'm going to give you the names. Okay, here's the names. This first one is isosceles obtuse. Of course, you could say triangle. It doesn't matter which word you put first, but it's an isosceles and it's obtuse because there's a gigantic angle right there. See that big angle? That's a really big angle. If you think about how much it's opened up. Okay, and then what else we got? We've got, this one looks equilateral and it's acute. All the angles are small. This one's a right angle. Which one is it? It's right isosceles because it has 2 the same. This one's right scalene because all the sides are different. And this one's acute scalene. All the angles are acute and all the sides are different. Okay, next one. Okay, we're going to name the parts of the angle. I'm going to do this on a piece of paper, but you can also look at this slide. Okay, with this triangle, there's a lot of neat things, and you're going to get a worksheet today and some interesting things about this. First of all, to describe this triangle, once again, let's name the angles, okay, and we use capital letters. So how about we use A, B, and C again? Doesn't matter which order. Okay, one thing you notice, which angle looks the smallest? Okay, so maybe I use some colors here. Here's this angle. You can, sometimes people use some pans and go, see how much that's open? And then you have this angle, and then you have this one. You should do colors, make him like purple. And then one more angle, make him like in orange. So one thing you notice, find the smallest angle here. Well, this one looks the smallest. If I'm looking at how much it opens up, it doesn't open up that much. So the smallest angle is right here. This is the smallest angle, right? This guy's the smallest. Well, where is the smallest side? Is it this one? Is it this one or this one? Well, it looks like this one. And to name this side, this is the short side, you could call it BC and put a line on it. It means connect B to C. Or you could say it backwards, or CB. And what everybody's seeming to notice is that the smallest angle and the shortest side are always opposite each other, which makes sense. If I started this, and as this is really small angle, this is going to be a short distance. As like I open up like these chopsticks, as this angle gets bigger, these get farther and farther and farther and whoa, and farther apart. So let's find the next biggest angle. The next biggest angle looks like C. He looks like the medium-sized angle. So go opposite to him, not touching it all the way across. This side here looks like it's the medium length. And lastly, this is the biggest angle. Whoa, look how big that is. It's obtuse. Then go opposite, not touching. Wow, that's the longest side. Okay. Sometimes people also use a small letter. This is the longest side. How would I name it? Well, A to C or C to A. Okay. Some people actually will use a short letter. They'll say if this is angle B, they'll call this side little b. And if this is angle C, they'll go opposite and just call him little c. And if this is angle A, opposite, they'll call him little a. Or you could just name the side, BC, or you could just call it little a for short. Okay, so there's some neat things. Next, so know the order, smallest angle, smallest side. That's something you're going to be asked. The next thing I'm going to ask you is about how long are the sides. Okay, so here's the sides again. If you drew a triangle like this, you would say, okay, where's the smallest angle? Right there. Here's the smallest side, isn't it? It's opposite. In fact, if you kept going, you can read this on your own. It's a little hard to see it all on here. But read this down in here. The biggest side is opposite the biggest angle. Okay, so if I look, wow, look at this length of this side. What's it opposite? This angle. Looks like the 90 is the biggest angle. Well, the smallest is opposite the smallest. Okay, so look at this. I want you to figure these out. Over here, I got three angles, A, B, and C. Put the sides in order. Okay, so pause it. Okay, so if I put the smallest angle is angle B. So what side is the smallest? Go opposite angle B, 59 degrees. That's the shortest side, AC. Okay, then I could go, what's next? What's the next biggest? It looks like 60. So angle C is medium, go opposite. Over here, that's A to B. A to B. And lastly, A looks like the biggest angle. Angle A. And go opposite. Ooh, that must be B, C. It's kind of hard to write in here. It's kind of interesting. Notice the letters are opposite. B is missing it. Okay, same over here. Look at this one. Put the angles in order. Pause it for a moment. You tell me the angles in order. All right, welcome back. Let's see. Here's the smallest one. So let me clear this up. Here's the smallest side. So what's opposite? F. The smallest must be angle F. And then I would go the next one. 10's the next biggest. Go opposite. Must be angle E. This is me trying to draw an angle. That's how I can be lazy. And then 11 is the biggest. So D. Okay, so be able to do that. Okay, let's talk about the lengths. A lot of this stuff, I skipped a bunch of slides. I was going to have you try to draw these, but one of these is impossible. So let me tell you a little bit about the lengths of triangles. Okay, if I were to make a triangle, I need three sides, but can you just pick any three pieces and put them together and make a triangle? Like, okay, this is 7, and this is 5, and then I'll just And, okay, and, uh-oh, that doesn't reach. Okay, I'll just use 10 and 5 and 1. Oh, there's a little rule about which pieces can make triangles. Can any of these actually work? I got a little problem here, okay? This piece actually I think is even longer than 10. So here's how this works. Let me get rid of these. Okay, so this piece is 7 and this is 5. What I'm gonna do is draw you. Here you are. And these are your arms. Whee! There you are, okay? These are your arms. And so let's make a triangle. If I said, let's stretch out your arms, and this is 5 and this is 7, what's the longest this third side could be? Could you stretch your arms to like 100? No, this is whatever units these are. This couldn't be 100, your arms aren't that long. But if you stretch it out the farthest you can get, well, what's 7 plus 5? The farthest you could stretch is 12, but wait, if you do it 12, you can't actually make a triangle. I want to connect your arms and draw in a triangle. I want to go like this and make a triangle. So the farthest you could stretch, well, 12, but then it wouldn't be. So it would have to be something less than 12. You can't get, if you get 12, then you're just doing your arms completely straight. So if you do a little bit less, this could be like 11 or something, couldn't it? Okay, so the longest you could be, so people made a rule that says add the short sides. Okay, 5 plus 7 is 12, but you can't actually be 12, you have to be less than 12. Could this side be 0? Could it be negative? No. What's the shortest this third side could be? If I were drawing a triangle, what if you bring your arms closer and closer together? It's a little hard to see on there because of the light. But if you brought them closer and closer together, what's the difference in the lengths there? Okay, well, the difference here, if I were to fill in this last piece and say, okay, my arms are like that. Well, if they're straight, it's not a triangle. I have to have them a little bit apart. What do you think you're going to do to get that piece? Instead of adding them, subtract them. Go 7 minus 5 is 2. So this piece has to be, well, if you make it exactly 2, it would be straight. So it has to be a little bit bigger than 2. So a trick, if somebody gives you a couple pieces and says, make me a triangle, all you got to do to talk about that third side, the shortest could be is just subtract them and go 2, stretch it out, add them, 12, and this third side, whatever it is, has to be, remember this, 2 is less than x is less than 12. It has to be between 2 and 12. It cannot be equal. Okay, so this is called like the triangle inequality rule. So some people write it down here and say officially this is how it would look. The two short sides must add up to more than the long side. No ties. The longest side can't be longer than the sum of the two short sides. Sounds kind of funny, but if I took some numbers like these, 3, 8, and 4, and say, could that make a triangle? Well, let's see. What do I do? Let's like pick the two short sides. What's 3 and 4 add up to? 7. Okay, what do they subtract to? 3 plus 4 is 7. What do they subtract to? 4 minus 3 is 1. That means this cannot be 8. It has to be a number between 1 and 7. So take the two short sides. They must add up to more than the long side. And the longest side can't be longer. So the easiest way, and it sounds confusing, just add them and subtract them and say, oh, it's got to be between 1 and 7. If you tried to draw that, if you tried to draw 3, 8, and 4, and you wrote something that's 8 inches, and then said 3 inches, 4 inches, well, obviously it doesn't reach, does it? Yeah, see, that's the problem, okay? So that's how those work. So tell me about this. Let me give you a moment. Try these, pause it, then come back. Okay, welcome back. So if I say, how long is this side? Well, I don't know. Minimum, what's the shortest it could be? So 8 minus 5. What is 8 minus 5? 3. It can't be any shorter than 3. What's the maximum? What's the longest it could be? Do 8 plus 5, 13. So this side, we could say 3 is less than x is less than 13. You know the answer is between 3 and 13. So the shortest is 3, the max is 13. Just add them up. Okay, one more to try. What are you going to do with these numbers? What's the max? Add them up. 17. This cannot stretch more than 17. If you try to say this is 1,000 miles, people are like, how can that be 1,000 miles if this is 7 inches and that's 10 inches? That's not going to work. Okay, so that can't be 1,000. The longest it could be is 17, whatever these are. The shortest, subtract them. 10 minus 7. 10, subtract 7, 3. So the answer is between 3 and 17. Pretty cool. Triangle inequality theorem. Okay, so now you get to do a worksheet. Okay, and look at the homework assignment for a photo of the worksheet. And when you're done, take a picture of it, show me that you did it, and then also, of course, compare your answers to my photo. And tomorrow and Thursday, just give a review of what we did, the basics, and well, maybe a couple other things. Friday, we'll have a test on geometry. Everybody needs to do the test. All right, goodbye.